I don't understand this.
Still on vacation.
Yeah, I usually can see. Is the recording on now?
Yes, it is.
I can usually see these people, this panel, but it seems to disappear. I don't understand why. Anyway, I'll get it right sometime or other. Ah, there we are. Maybe that'll help. Ah, there we are. Sorry. Got my act together finally. I've been away too long. But there we are. Now I can see you all and everything is as it should be. Right. Please, guys, this particular section, Bernard, you know you've disappeared completely, hey?
Oh, I'm having trouble with my avatar. I don't know. Okay, so I'm here.
Yeah, okay. You must have chosen the invisible man. That's all I can think of.
It's just that it's turning and turning and does not, offer me anything. So I just turn on avatar, but okay, I didn't know that I was invisible.
No problem. Okay, this particular section I've put in, it started with your question. You want to know about pointers and user spaces. And I thought the first thing we need to discuss in great detail is pointers. And it's very important that you guys understand exactly what pointers are and how they work and what you can do with them. Because they are, in my mind, the most powerful thing that's ever been added to RPG on the IBM I. And they can be used for just about anything you can imagine. But it's important to understand that the way they work and how they work. So I'm going to take a little time on pointers, and I need you to stop me and ask questions whenever you feel it's not clear or I'm being too vague or not explaining it well enough. All right. So let's begin. Pointers. It's a type of data element. That's all it is. It's like a character field. It is defined. It's actually like a binary numeric field more than a character field. It is defined in RPG for either using a star if it's a fixed form, or the word pointer if you're in free form. Now, I'm assuming most of your new code is happening in full free form. So it would be the word pointer that you would use to define a pointer. But what do you get? And that's the important thing. What you get is you get a 16-byte, 128-bit binary data element. That is an unsigned binary data element. Now, if you have the inclination and the time to sit with a calculator, what the actual size of that binary element is 1 times 2, 128 times, and every result added up all together. That is the theoretical maximum memory space that the IBM I can manage. It's a big number. I tried it. I only got about a quarter of the way, and it ran out of calculator space. So it's a very big number. It's in the terabytes. But a pointer is basically nothing more than a number pointing at 1 byte in the memory. Now, IBM I is a virtual storage system, i.e., memory and disk are seen by the operating system as one big space. Where byte naught is, I have no idea. But a pointer, which is actually called two things. It's either called a user pointer or a base pointer. They both mean the same thing. It gives you the number of a byte from 0, wherever 0 might be. And you don't even want to know where 0 is. Okay, so that is what a pointer is. It's simply a number. But it's a number which is used as an address. It's an address or a byte count from 0, wherever 0 happens to be. Okay, so let's see. A pointer, when it's populated, contains the actual address of a single byte within that storage space. So it's pointing to a byte in that storage space. Simple as that. It's a very simple thing. It's not a complicated thing at all. But empty pointers are pointers that have not been initialized, carry a null value, star null, and you can test them for star null. So you can see whether they have a value in them or not. If you define pointers within a data structure, they must be aligned to a 16-byte boundary. Now, this might sound terribly complicated, but in 99.99% of the cases, it's actually not, because it will automatically align. If you put your pointers, if you want to define pointers, you put them up the top of the data structure, they will automatically align to a 16-byte boundary. If you want to force alignment, and you're not sure, you can use the keyword align, and the compiler will automatically align them to a 16-byte boundary. So although that is a rule, it's not a very depressing rule. Right, now, the next one is the most important thing of the lot, is that because a pointer is a binary numeric number, it's unsigned, you can add or subtract from it, effectively moving the pointer up and down the memory space. The IBM I operating system will not allow you to move the pointer outside your job space. You know, each job you start on the IBM I has a job space. It's got boundaries, and you cannot add or subtract from a pointer that will take you outside that boundary, because the system will crash. It will say you're trying to address a space that's not part of the job, and then it will just sit down and quietly cry in a corner. So you are protected from doing something completely stupid, but you've got to be careful and understand what you're doing with pointers. So I've devised a little game we can play. And here's where you've got to participate. I need answers. I need you to try and understand what I'm going to do now. I have declared a data structure. I've called this thing and given it a length of 210 bytes, and that's the end data structure. It's all in one statement. That is just declaring myself a space. I chose 210 because of the size of the slide and the fact that it's 30 bytes across and there's 7 rows deep. That makes 210 little squares you can see there in front of you. That is a space. Now, as that definition stands at the moment, I can only address it as the full 210 bytes. I can address it as a data structure of 210 bytes long. I have no way of messing around with anything inside that data space. Are you following me? Please wave a hand or something if I'm anywhere lost, any of you. So let us see what I'm going to do here. I'm going to declare a standalone field called a user pointer. And I'm giving it the type pointer. And I'm going to use a built-in function here. Percentage ADDR thing. Now, percentage ADDR is a built-in function that can initialize a pointer with an address. So executing that initialize statement will actually put a value in the USSR pointer, the user pointer, which is actually the address of that byte in the memory. Now, it's somewhere, but that is actually what that address will be pointing at. Wherever that data structure happens to be, it will be part of the PAG, the process access group for the job. And wherever it happens to be stored, that address will point to the first position. Okay, now, having established a value for the pointer, we can now declare something like this. We can declare a standalone field, field 1, a zoned 5-byte, and we can use the based keyword. That's why this is called a base pointer, because we can use the based keyword and we say this field is based on the user pointer, i.e. it's based on the value of the user pointer, or to put it another way, this field overlays a 5-byte space starting at the user pointer, which means that field 1 at this point in time in the program contains the value 1, 2, 3, 4, 5, zoned numeric. There it is there. But here's where it gets interesting. I can also define another field, field 2. I can call it character 5, based on the same pointer. It's overlaying the same space, and therefore is a perfectly valid character 5 field containing 1, 2, 3, 4, 5. Wonderful. Then when I define the third field, called this, which is also based on the same pointer and therefore begins at the same point in that data structure, what would happen if I tried to use field 3 in a calculation? What would happen? Anybody can offer me something? No. No takers. You would get a decimal data error. Why? Because a packed 5 field is only 3 bytes long, and it would mean that you would be addressing only those first 3 bytes, which are not valid packed numeric field. Does that make sense to you? I'm being a real pain about this one, but it's got to be understood how this thing works, because it gets harder than this. You know what's wrong with avatars? I can't see the expressions on your face.
Well, I'm wondering, in a pack field,
Yep.
We would see on the first pointer, we would need 1 and 2, and on the second one, 3 and 4. Basically,
this field here that I've got down the bottom here, that's actually what this field would be looking for. It's 1, 2, 3, 4, 5, F.
Yeah.
You see,
Okay.
so this would be at this point with the pointer set like this. It would be looking at those 3 bytes, which is not a valid packed numeric field.
Yeah.
So you would get an error. Now, let me play a game with you here and let's see whether you follow me some more. You other guys can talk. It's not only Bernard that has to talk. Here I have defined, I've defined a field called offset. And it is an unsigned binary, 10-digit binary field, which, as we all know, occupies 4 bytes. I hope you all know that that's a 4-byte field. And I've initialized it with a value of 67. I wasn't very smart when I did this because I should have got the numbers more sensible, but it's easier. Now, then I'm going to execute a statement called this. I'm going to say user pointer is equal to the user pointer plus the offset. Now, the minute, the second, the microsecond that I do that, the value of pointer changes. And therefore, all three of those fields shift. Because they're based on a pointer, the pointer has changed. Therefore, these fields shift automatically. Does that make sense? Are you clear? I've added 67 bytes to that position, right? And therefore, all these fields suddenly shift. And this is what's so magic about pointers, is that you can move around a space by just changing the pointer that you're using for addressing. So let's see whether you can guess right. I want you all to, on a piece of paper in front of you, I want you to guess where that is going to point to. By the way, I don't know whether you know this, but this is the long way of doing this addition. The other way of doing it is you can do it like that. That's the shorthand version, which also works. The plus equal and the minus equal. I don't know whether you used it or not, but I'm throwing it in there for bonus. Where do you think you are going to be pointing? Let's count. Each row is 30. So there's for 2 rows, that's 60. 61, 62, 63, 64, 65, 66, 67. Can you see my little green arrow?
Yep.
It keeps disappearing. Why does it keep disappearing? So logically, you would think it was going to point there, wouldn't you?
Mm-hmm.
Except it's not.
But
Why? Because that byte there is offset of 0. The first byte that the pointer addresses is
that is
0.
0. Okay, this is 0. All right.
Yeah, this is the thing you've got to get into your head, and you've got to understand it. It's different from a data structure. The first field in a data structure is from 1 to 5. So if you define this field in a data structure, you would define it in position 1 to 5, correct?
Mm-hmm.
Mm-hmm.
If you're addressing it with a pointer, the pointer is at offset 0. So by adding 67, I'm actually going to be pointing to that A, not the byte before it, because that's 0 plus 1 plus 2 plus 3 plus 4 and so on makes that one 67 there, not that one. Right. Can you absorb that? Just because this is really the key to the whole management and use of pointers, is there's 1 byte difference between how we define data structures and how you manipulate pointers. Pointers always start at offset 0. And the number of times I've made mistakes in calculations, I couldn't tell you, where I end up 1 byte wrong. And as soon as you see you out by 1 byte, you know exactly what has happened. Okay, having changed this user pointer, which of those 3 fields is now valid and which are not valid?
So we're going to have a decimal error again, because the field 1 and field 3 will not compute.
Exactly. Only field 2 is valid.
That's correct.
So in the first iteration, field 1 and 2 were valid. Now only field 2 is valid. See, now let's do something else. Let's do this. Now, this is the second thing about pointers that you've got to bury into your mind very clearly. User plus equal offset plus 26. Where does that point to?
Offset is 67, 80, 93. 93 plus 1.
My guess is if you thought how most people think, you would have got that.
No, because offset is 67. So 67 plus 26.
Okay.
So,
sorry. This was a trick question that was deliberately done. Remember, I've already changed the value of user pointer I've added the offset. Here I'm adding the offset for a second time.
A second time, okay.
Plus 26, because I moved it once on that statement, and then I did it again plus 26.
Okay.
You get me? It should be user pointer plus 26, and that would give me that position instead. You've got to remember that the pointer is where you left it last. It doesn't automatically go back to the beginning just because you think it should.
Yeah.
Okay. There are many ways I could have dealt with this. I mean, and you can understand them. I could have said, make the user pointer equal to the address of thing plus 26. Or plus offset plus 26. I could have achieved this result in the same way. So the how you get there is irrelevant. The important things to understand are, first of all, that the user pointer addresses a byte at offset 0. I'm going to say that a dozen times between now and the end of the next 2 weeks. The user pointer is pointing to offset 0, so you're moving a pointer with arithmetic either forwards or backwards. You must understand that you're starting from an offset of 0. And wherever you leave the pointer, that's where it stays. Now, pointers need to be initialized for each new activation group. That's another thing you've got to understand. You can't carry a pointer from one activation group to another. Except you can, but I'll show you another way of doing that. For the moment, let's not worry about that. Remember, activation groups manage resources. Do you remember? I said that to you a couple of weeks ago. And one of the resources that activation groups manage is pointers, or variables, in fact. So activation group pointers are bound to activation groups. So if you move into a new activation group, you might have to initialize your pointers all over again, but we will worry about that later. Okay. Have we got it, or shall I repeat it again? A pointer addresses offset 0. And a pointer is always as you left it last. What I do when I'm playing games like this and I want to hold an address is I create 2 pointers. The first pointer is the start of the data structure that I'm playing with, or the structure that I'm playing with, and I don't change that. I keep that. Then I have a second pointer which I use to base my values on, and I move the second pointer around, but I can always move it based on the original pointer so that I can always going back to the beginning again. That makes life a little bit easier. Okay. There are many ways of playing this game. The important thing is to understand it. Having got this pointer now addressing this, which of those 3 fields has become valid? Really? You got it? What's happened? Oh, no. Can you guys hear me?
Yep.
Yes, we can.
My screens have gone completely blank. They've just dropped out. You're not seeing anything. How extraordinary.
You received a response on the signal message, Tom.
Yeah, I know, but I don't know
So
why.
just might be, in actual fact, just try refresh or whatever.
You lost the pointer.
Let me tell you, that's not. Oh boy, I've got no keyboard. I've got nothing. That. All right. Look, I don't know what to do. I don't. This has happened to me before, and I couldn't understand. It's something to do with Microsoft Teams, I think. Alt escape. No. I've still got you there. I've just lost my screens, which is very odd. Why did it do that? I presume.
Tommy, you were saying something. You started with, I presume, and then you froze up. Okay, well, just sit tight. I'm going to try and see if I can reach Tommy. Okay, Tom will be with us shortly.
Okay.
He's got his screens back. He's just rejoining.
Right, can you hear me?
Yes.
Don't ask me what happened there. I wouldn't have the vaguest idea. Anyway, right, let me just go back to sharing again. And you were probably right, it was a pointer. Diane's back too. For a moment, her avatar went AWOL. Right. So at this point, I think I was saying to you that only the third field 3 is actually valid. The other two have now become invalid. Was that what I was saying to you?
Yes.
Okay. So this is just an example of a pointer and what you can do with it. You can address, there are various different ways of giving a pointer an address. That's one of them. Percentage ADDR is you can use that to address any variable, any data structure within your RPG program. So you can use it, and I'll show you various different ways over time of how this thing is used, particularly when we come to user spaces. But percentage ADDR will give you an address of something. If you wish to address a variable length field, varchar, you can, there's a second keyword on address that comes in here. If you want to set up the address of a pointer of a variable character field, you can either set it to the first byte of the field, which, as you know, contains the length of the variable byte of the variable length field, Or by using star data after the name, you can set the address to the first actual character of the variable length field. So you've got, it's a slight variation on that. And I'm going to see whether I was smart enough. Was I smart enough? Yeah. Built-in functions. See, I can actually use the manual sometimes. I don't have to do PowerPoints. You'll notice here is the address of a variable. The variable can be anything. It can be a data structure, it can be a constant, it can be a variable of any sort. If it's a varying length variable, you can use the data keyword to set the pointer to the data address. If you don't, it will set it to the length, the beginning of the length. So that's your one choice of how to set a pointer address. Now, there's another one that is, to my mind, quite fun, is alloc. Allocate storage. When you use this alloc, and if you look at the example, you will see it there, it returns you a pointer. Now, this is a pointer that it returns is an address in heap storage. Now, I haven't, if any one of you has any idea what heap storage is, you can tell me, because I have no idea what heap storage is. But all I do know is it is part of the operating system storage areas. It runs at priority 0 as part of the operating system. And you can actually allocate a length, a block of a certain length, the number of bytes that you want to use as heap storage. You want that piece, and you want to allocate it in main memory. That's an option that you have. It's very fast. I've never used it because I've never found any need to, but you know, some of you youngsters might like to play a little with it. That's the other way of allocating a value to a pointer, is if you allocate heap storage, you can specify how much you want, and then if you want to change it, you can use the built-in, I think is it a built-in function? Yeah, you can use the built-in function reallocate, which changes the size. You put reallocate, you specify the pointer that you had, give it the new number, i.e. I want it bigger or smaller, and it will return the same point. You use the same pointer, and it just changes the size of your allocated space. And then, strangely enough, and I do not know why they did this, if you want to free up the storage, you have to use an opcode deallocate. They haven't given you a built-in function. They've given you a built-in function to allocate it, to reallocate it, but not to deallocate it. Again, not my problem. So that is a way of getting a piece of the memory, the main memory for your job, and utilizing it for storing. Obviously, it's temporary storage. You cannot save it, and you've got to manage it yourself. It's just a big empty bucket that you've got to fill up. Yes, Ludwig.
Do you need to set a type for the allocation?
A type for the allocations. That, well, it is a pointer. It has to be a pointer. When you say type.
So let's say if you want the char inside The
Oh, well,
structure. Do you need the-
then you do it exactly the way I had it. That you simply set the pointer, you allocate it, and then you base a field on that pointer.
Okay.
So using the allocate, you would simply get yourself a pointer, which is basically the same as this pointer we had here, which is addressing. So this here could say allocate 210. And what you would be dealing with is exactly what we had here. But instead of being a data structure in your program's memory, you would be dealing with a 210 character space in the system memory. That makes sense.
Yes.
Okay. So you can set up a data structure. For example, I can allocate myself 210 bytes. Then I can set up and define my declare data structure thing, length 210, based on pointer in data structure. So I can base my data structure on the allocated memory. So I can take my data structure and put it into the system memory, the system's main memory. As I say, I've never done it. It's available for high performance stuff, but most standard applications don't need that type of performance. So I hardly ever do it. Okay, but I have to tell you all the ways. So you now have heard all about pointers. Do you have any questions at this stage? Ludwig, we just had one.
The question is,
yeah,
pointers within normal program function. Normal program probably is working in the background with pointers all the time. Okay, we just don't know it. But so there's no need for pointers within a program. I don't see a big benefit unless you're gonna tell us what is the real benefit of pointers down the road.
Right. Imagine this. Have you got any programs that use arrays?
Yeah, a lot.
Hmm?
All of them.
They use arrays. Do you write stuff into an array and then read it out again?
Yes.
Use one big data structure and address it with pointers. Each entry can be defined as a data structure. You can have multiple entries in the data structure, and your data structure can reoccur multiple times. So let's, for example, say I make a data structure of 5,000 bytes, and I have a recurring data structure of 20 bytes. Okay, that's got 6 fields in it, totaling up 20. I can base the data structure on a pointer and set the pointer to the beginning of my 5,000 bytes. Then I base the data structure on that pointer. So the data structure exists in the first 20 bytes of that 5,000 because the pointer's there. Then when I've populated that data structure, I can add 20 bytes to the pointer, and that moves the pointer down the structure 20 bytes, effectively moving the data structure down the space 20 bytes. So I have a nice new fresh data structure. I've stored the values in the previous, and now I'm populating the second one. And I just keep adding 20. Okay?
I'm supposing that this is the way that you're using the I/O server. You should read data and use the pointer to read the data from another program.
You can.
I think.
You can use it for arrays. You can use it for, do you use a multi-occur data structures? Do you use DS with the occur 20?
Mm-hmm.
You can do it. You can use a pointer for that. I'll get there, Lufik. You can use a pointer for that. It's probably about 150 times faster to use pointers than to use recurring data structures or arrays. It's that simple. It's just fast and it's easy. I can have a counter to tell me how many entries I've got in my array. If I want to go back to the beginning, I can reset the pointer to the beginning and then read down it again and read backwards up it again. All I'm doing is adding or subtracting 20 bytes at a time, and I can read up and down the various array of data structures. So there are many uses for pointers. This is the point. And you've got to begin to think outside, a little bit outside the box. Luvik, what you got? Question?
When you use allocate, do you need to deallocate so it doesn't reserve memory space?
It's advisable to do that because that's the tidy thing to do. You don't have to, but when the job ends, that space will be recovered anyway. So trouble is if you're allocating large amounts of heap storage through the allocate, you may start sucking up available spaces for other resources as well. So you've got to be careful when you use that. You should only use it if you really want high-speed, very temporary storage, such as arrays or multiple recurring data structures or things like that, where you're writing into and reading out of them and you need it to be very quick. The one thing I can think of is subfiles. Very fast. Very nice and very easy to handle subfiles. But I haven't used a subfile in 25 years, so I am not the person to talk about that. Okay, anything else before we move on? This will come back again because remember, I'm talking about pointers here. I haven't even started on user spaces yet. Okay, there's another use you can use pointers for. If I'm in program 1 and I initialize a field using a pointer, now that pointer carries the address of that field. If program 1 calls program 2, and I pass that pointer through to program 2 as a parameter, then program 2 can base a field on that pointer and it's looking at the field in program 1. Does that make sense?
I thought that user space was initialized every time. Okay, so this way, if we call program 2, it must be into the caller activation group, in the same activation group.
Yeah, it has to be in the same activation group. We will worry about splitting them up. I've got something that'll show you where a possible split needs to come from. But most of the time we're working in one activation group. You step down an activation group for very specific reasons, and then you would reinitialize pointers. But say I have a data structure. It's got 20 fields in it, and I populate 20 fields in program 1. Okay. Now I want to pass all 20 of those fields down to program 2 in order for program 2 to process them. The old way of doing it would be to call program 2 by using a parameter list with 20 fields in it. Am I right or am I wrong?
Yeah, that's the way it is.
Here we do. In program 1, we set up a data structure. It's got 20 fields in it. We set up a pointer, which is set to the address of the data structure with the 20 fields in it. And when I call program 2, I pass the pointer as a parameter, as a single parameter to program 2. Program 2 has the same data structure based on that pointer. So the value of the fields is passed to program 2 via passing of the pointer, which is addressing the data structure.
Okay.
And this is why I say pointers are fantastic, because you can do so much with them and it makes life so simple. And when we come to user spaces, it gets even better because you can pass those outside activation groups and even outside jobs if you want to. We'll talk about that later. Okay. So far, so good. Any other questions? I know there's probably going to be plenty more when you start playing with this thing. Okay. Can I move on to the next topic?
Yep.
I/O servers. I've chosen to do this next because this is part of will allow you to play with error handlers and give you introduction into the concept of I/O servers. And we now have, I presume you have those 2 files in a library. Okay.
Yeah.
So your homework, if we manage to get to the end of this session, will be to create 2 I/O servers for those 2 files that are in that schema. Right, let's get on. Why I/O servers? Why do we want an I/O server? People have asked me this over and over and over again. Surely I just put an fspec in my program and I read and I write and I do whatever I like. Why do I need an I/O server? I/O servers are not officially part of the database, but from my perspective, they are part of the database. They're what I call a border control. They provide input-output services to the applications on behalf of the database, i.e., you never have another fspec in a program. You use the I/O server. And let's have a look at some of the things. This is what we do traditionally. We have an application program A, and we open a table. We want to read, write, do anything with the table. This is typical traditional stuff. So the open data path is created for the table. Remember, this open data path resides in the PAG. Are we all comfortable with the process access group of a job? All variables reside in the process access group, including open data paths and file definition tables, and all the information that relates to that job are part of the PAG. In the old days, we used to have problems with this because insufficient memory meant your PAGs had to be kept to a minimum. It's not so bad these days, but the smaller the PAG, the better the performance. Now, what happens here is we now call program B. Now, program B wants to also process records in that table. So it opens another path and the PAG doubles up because we have another open data path in the PAG. We've all been there. I'm sure you know what I'm talking about. My record is 710 simultaneous open data paths in one job. It wasn't my programs, it was somebody else's, but that was what we had. You can stop this by doing that. I presume you do it. Have you used the override database file?
Yes, a lot, but not in that case.
No. But you have to call it via a CL program, don't you? Because override database file is a command that you can only run in CL.
Mhm.
But doing that reduces the open data path. It's a shared open data path, which means both files have access at the same time to one data path. That's the traditional way we've always done it. So why do we need I/O servers? Well, let's have a look. Let's start with application program A and table. Same as we had before. But this time we're going to put in an I/O server in the way. Now, This IO server, and I will show you the code in detail shortly, is always, it's actually part of a service program. We make them a service program and its activation group caller. So this iteration of the IO server will always operate in the same activation group as that one. And of course, the IO server is responsible for doing the open, building the PAG FTT and the open data path. And it actually does the IO on behalf of the application program. No FSpec in the program, you just have a procedure call to the IO server. Okay, now, RDBMS also, of course, handles the before and after triggers, if there are any, which we will be coming to. And those are also compiled with activation group callers, so they remain in the same activation group as the IO server, which is in the same activation group as application program A. Now we call program B. If the activation group is star caller for program B, the IO goes through the same IO server, same RDBMS, same FTP and ODP, and to the same table using the same before and after triggers. All very nicely, thank you. No hassle. Single open data path, and the IO server is servicing both programs. Huge benefit here. Program A can do the read for update chain. Program B can do the update. Because it's in the same IO server, so you don't get a attempted update before read situation. I can read a file out of this using this IO server. I can read a record here, and that record becomes available to me in program B. You're using the same code. Again, you could have pointers. There is a pointer involved in IO servers here, which means that the actual record buffer that is being held in the IO server here is addressed by a pointer. And it's available to both these programs equally. You're passing the address of that data structure backwards and forwards via a pointer. There are a couple of other things. If I want a second open data path, if I definitely don't want to use the same open data path, but I want to force a second open data path, I just change this here to activation group new. That puts this program into a new activation group, which causes a new iteration of the IO server and a new iteration of the open data path. And you have a completely separated circumstance. It's not common, I have to tell you. You'll be surprised how uncommon it is to want to do this. Also, just as a matter of interest, when you call an IO server, the way I've designed them, the first time an IO server is called, the file is opened. After that, the file stays open in that activation group and can be called from any one of 100 programs in that same activation group. The file will remain open. There's no file close, file open, file close, file open. There's none of that. It's a very stable one open, and only closes. I never close a file. I only close a file when I exit the activation group, because then it does it for me and I don't have to worry about it. So that's another advantage of the IO server. But to my mind, the most important part of this IO server business is this one. We're all a little nervous these days about security of data. Reason is very simple. There are too many hackers out there. There are also too many SQL clients out there. And a SQL client can access the database of an IBM I machine relatively easily. So how do you protect your data? It's not that easy. The IBM I has a very nice object authority system. And what I do is I make sure that I create a user profile on my system, DB owner or whatever you like to call it. And the table, the IO server, and the triggers all belong to the database. They are all owned by the DB owner. And remember, an owner has, by definition, got all object authority. The applications have an application owner, and they have application owner. And then, of course, the other owner is the operating system, which is these gray pieces, which I don't worry about. The operating system deals with that. Now, in this scenario, what do? I want to protect my data. So the first thing I do is I slap one object authority on my data table. Just one. I don't have to authorize every single individual user to every single level of access to the database. I simply say public exclude, i.e., with the type of authority that the IBM I offers in object authority, nobody from any other client, anywhere else in any system, in any way has access to that data table. They don't. Even if they are authorized users of the IBM I. You might have your own profile on the IBM I. You can't get at that table because it's public exclude. Even if you fancy with SQL and you play on the keyboard and you make a SQL client and you've got authority to the system, you can't get at that table. Secure. How do I then make it available for my applications? Well, that's actually quite easy. First of all, I make my application programs public use. I can authorize access to most of these things. I also, the IO server is public use. Now, what is very interesting about this is the IO server is a module, right? It's a module in a service program. When these service programs are compiled, they adopt owner authority. If I use any term you don't understand, stop and make me repeat it. The IO servers are compiled to adopt owner authority. So are the triggers. And of course, so is the table. They all adopt owner authority. The application programs are public use. They adopt owner authority as well. Now, that means if you have access to a program and the program uses an IO server, it adopts owner authority. The owner is the owner of the table, therefore the public exclude doesn't apply. And the owner has all object authority, so I don't have to specify anything as long as I'm coming in through a program to the IO server. The IO server is a module inside a service program. It's not directly callable from any interface that can be driven from a keyboard. You can't call the IO server. As a result, only if you have access to an application program are you able to use that program to access the data in the table. And of course, that's all managed through the triggers and constraints and the IO server. So you can only do what is allowed in terms of what the IO server can do, what the triggers allow you to do, etc. And that is then locked down your database to absolute minimum access. Only authorized people can use the database. And to me, this is the most important part of this IO server, is the ability for a simple data lockdown so that it cannot be abused in any way whatsoever. I like these IO servers. You will see as we go along, I'm going to make you use them, and you will begin to love them like I do because they're actually so easy. But you'll have to take, sorry?
What about then ODBC access to the tables? How do you do that after that? You have to duplicate the data to tables, to available table, to read-only tables.
You could create, you see, you have a problem there. You do ODBC access. That's through SQL, basically.
Yes.
You've got to authorize those people because you don't want to open ODBC access to all and sundry because, as I said, there are so many clients available on PCs these days that use ODBC that if you open up to ODBC, you've got the possibility of a lot of clients using ODBC to get into a file they're not supposed to get into. That is why we have actually are proposing, what you will see later on in this whole exercise, to use IO servers or JSON drivers to provide access to the database so you don't have to use ODBC.
I think, Tommy, if I can butt in here, I think that the question specifically relates to the current production situation that Bernard has, where he uses a lot of ODBC drivers for the dashboards, etc. That is in use, and specifically, I think some of the tools, the EIS tools that he is using. Bernard, the issue, and I'm just going to briefly mention it because this can be a whole subject on its own, is that SQL injection is one of the things, and you don't often hear of it within the IBM I context, but you will see that most of the hacking attempts globally is typically achieved through SQL injection. And the kinds of things people can do, it's scary.
Mm-hmm.
So
yeah, I know about SQL injection, but us, let's say, just talking about Power BI, for example, for us, it's so easy. We build views and we just synchronize the views with Power BI, and that's it. But with this situation, the views, I don't know if we can, yeah.
You see, then what you do is this is the public exclude is the maximum lockdown you can get. If you're using Power BI, you've got to give people access to the data. They've got to be able to read it. So what you do is you change this public to star use. You follow me? That means your Power BI will be able to get into these tables via ODBC to read them, but not to update them or change them or in any way mess with them.
Okay.
And so you've got to grade your authorities to suit your application. As I say, I love my job because I can do the ultimate, right? Theoretical ultimate. It's the perfect environment and I love it. I don't have to work with it. Other people do. Okay.
No, but I like that to have only public use. That would solve my problem.
But your applications, because of the IO server and the adopting of the authority, would have all other authorities necessary for application, without having to go and mess with large authority tables, you know, auth lists and all that sort of thing, which really, years ago, I had one of the mines here, I had to do a query course, Query 400, for their personnel department, because they couldn't develop the reports fast enough, and they wanted to teach their personnel how to use Query 400 so they could pull their own reports. So I said, that's super. I can run a course. It'll take a day. And what you need to do is you just need to give me a logon, and you need to give me authority to the database that you want these people to work on, so that I can use examples and show them how to do things. The guy said to me, okay, he said, we'll have to book that then for 2 weeks from now. I said, 2 weeks? He said, yeah, it's going to take my security guy at least that long to get you authorized to all the files. They were actually authorizing individual users to individual files at individual levels of authority. They had one guy full-time doing nothing but putting new staff in and taking old staff out of their security definitions on their database.
Oh.
So I thought, when I saw that, I thought, no, I must find a way of making it easier. And this is the easy way. And this is the big plus of IO servers. Okay.
But just another question, Tommy, sorry about that, to slow you down, but it's quite a big change for us, because let's say today we want to make a change to a file. We're gonna do a small analysis, an impact analysis, and it's going to tell us, okay, here are all of the programs that is using this file. So now what are we doing down the road?
Right. The first thing is, you must understand what I'm proposing here is the ultimate ideal. You're never going to do this to all your programs all at the same time. Please don't misunderstand the purpose of this whole methodology. There's no big bang solution to this. You can't do it in a weekend. You can't.
No, I understand, but let's say we are into that model of IO servers.
Right.
And how do we do the where used after this? Since we don't have any F spec,
the F specs in the IO server.
Yeah. So now how do we know that application A is using table A?
Well, the IO server is defined in the application A. So you don't look for the F spec, you look for the procedure definition.
Okay.
And I'll show you my naming convention when we get there next. My naming convention is very carefully designed over years to make it easy to do exactly that sort of thing. You see, application program A and program B, they will both have the file definition specification for this IO server in them. So, and the actual IO server has got the name of the file in it. So you're looking for that name, and it'll show up in the program as well as in the server. Okay. That's why, actually, when we get to that point, which is where I'm going right now, the naming convention that you adopt is actually quite important. It's not mandatory, and it's not broken if you don't, but if you can develop and it could take years to change a naming convention, this is the problem. So we would have to see. You have to take this one small step at a time. Remember something, I can have one program using an IO server and one program accessing the same table with an F spec. I don't have to have them all of a sudden using a server. I can do one at a time as I feel the need to. Okay. Anything else? Any more?
Oh, it's good.
Right. There's a little thing while I just find my other screens, which I've got to come up with. Yeah, it'll be this one.
This one's got long hair.
Yeah.
For a hot country like this. Huh?
Yeah, he's actually quite a rare animal, that one. He's not common. But he's one of our antelope, one of our. Well, he's you find him deep in the bush.
Okay.
Okay. What I've done here is I've got some code from AO, and this is an IO server for that file there, AOF 100F. Now, all my files have been always named like this: 3 alpha, 3 numeric, and an F at the end for a physical file, because although a lot of people don't know it, that's how you spell physical. F-I-Z-Z-I-K-A-L. And these people who think P is the way you do it are wrong. That's a file name. There's the F spec in this IO server. Now, this IO server is a module. I don't know what you chose as your type code for modules, but I use RPG LEM, which is the IO's, RDI. I've set that one up for a module. Notice the F spec, open for update, delete, and output. This is a general purpose standard IO server using RLA, record level access, not SQL. Nothing to stop you making it SQL if you want to. I like record level access, and I've always used it, and it certainly, to me, is easier. It's keyed because naturally all physical files should have a unique key. It's defined as a user open, i.e. this program will open it. It uses the commit keyword to say this file is under commitment control. Now notice that definition there is in the IO server. So if you were using the IO server, there's no way that you can accidentally not put a file under commitment control. It's got to be under commitment control because the IO server requires it to be. And this is, I renamed the actual record to R1, but that's something that goes away when I show you. Then there's a few constants. I've got the file name there. I've got the server name there. Notice my convention, my naming convention for IO servers is the file name plus $1 at the end, which means when I'm using RDI and I want to find all the components, or all the components for a particular file, I can just subset this AOF 100F star, and I can see all the components. There's the module, there's a module, there's a logical, read-only logical, etc. So I always name my files from the left to the right. So that convention is what I use. And this indicates an IO server. The dollar at the end indicates the IO server procedure. That's what I would call. I have a record pointer, which is identified as a pointer. There's where the pointer comes back in again. I have the record key, which is like record R1 key. And I have the whole record itself. The record for the external file name, which is that constant. Notice that the record data structure is based on the pointer. I have a save rec key and a save record as well. You're going to have to go through this and understand the code, but this is what an IO server looks like. There's my error handlers. one for moving diagnostics and resending escape messages, and the other just to send escape messages. Those are pretty much the only handlers I use in an IO server. And this is the action code, because my IO servers all operate on 3 parameters. 3 parameters. Every IO server has exactly the same set of parameters. And in fact, this procedure is what they call a function, because it actually returns an indicator to say yes or no, and that depends on what you called. If you did a read, it would come back and say, yes, I read something, or no, I didn't read it, or whatever. But there are 3 parameters. The first is the action code. What action do I want to I want this IO server to perform? The P is the pointer. I'm sending a pointer to this IO server. And the pointer is actually the client sending me the pointer for this records data structure in the client program. The application program A has got the data structure, and it's got a pointer, and it's sending me the pointer. So this pointer addresses the records data structure in the calling program. Does that make sense? I need to,
Yep.
You got that. So that's how I pass the record backwards and forwards between the program and the IO server, is I just have a common pointer. My record is based on that pointer. So if I put anything into this record, it automatically appears in the program's record. Okay. And then the last thing I have is a key, which is options no pass, because it doesn't have to be passed, because it's not always in use. Right. Those are the 3 parameters that I have found work the best. I haven't needed for years. Those 3 parameters are completely standard, and they're completely standard on the, I don't know, 150, 160 IO servers that I use in the AO product. So I'm pretty certain that you would be able to use these exactly as they are for yours. We will find out. The first thing this process does is it does an open, i.e. it calls a procedure called open. By the way, this is one of those syntactical things where this is a call procedure, but in free form, you don't have to put the call procedure in there. The 2 brackets following the name indicate that it's a call procedure, so you don't have to put in the opcode, just to make it easier to read. The open statement, if it's not open, open it. Otherwise, don't. Start of procedure, end of procedure. Simple. And this will only ever be done once. No problem there. Right, then I do a couple of other things. I move the A, which is the action code, into a data structure. I move the P into the record pointer. That's this P. I move into the record pointer. And then I check for the 3rd parameter to see whether you've passed the key. If you've passed the key, I use it from K. If you haven't passed the key, I pull it from the record. Are you guys familiar with that opcode? Eval corresponding.
Not me.
Anybody else?
No, I don't. I don't.
You don't. It's super. I love eval corresponding because it does things that are wonderful. Let me explain this one in particular. This moves record to record key. I'm populating the record key data structure. Let me just get rid of these lines in between here. Right. Here's, I've got the record key as a data structure. like record R1, but the key fields only. So this data structure is a data structure of key fields only. This record is the full data record for the full file, okay? Eval corresponding moves everything from here, that data structure, into that data structure where the name and the attribute correspond. Which means that I can use that one statement, whether there's one field or 20 fields in the key. It's a single statement and it works every time. It moves fields from record that have the same name and attributes into the record key data structure. So it's a data structure to data structure move, which does not have to be equal. You like?
Very interesting.
Yeah, you've been paying for it for years.
Yeah.
Okay. So that's how I populate the key. Right here is really your select when, and these are the opcodes that are coded into this IO server. Input, update, delete, read, close. Anything else returns an error. Now, here we are with the error handler 11. In your case, it's going to be ERR. Okay, not ERH. Watch out for this. You're going to have to change some things. The number is AOF 19999 from error message file. It's the IO server name plus the action is the substitution data for that message. And that simply says you've tried to use an action code that's not supported. That's simple. That goes back. Sorry.
I will hand my. I have two questions.
Yeah.
First one is, what's about the set lower limit within the code? Is it one case that we can use?
Set lower limit.
Yeah.
It's here. Is that what you were asking? It is here.
No, I don't see the set lower limit option. I've got the read, the delete, the update, but the read will be always the same as a read record.
It calls a get routine. Look there. It returns the pointer received from the get. Now we'll go and have a look at the get, because get is where the read is. And there you will see if the second position, the first position of it must be an R, okay?
Mm-hmm.
Or an S. Oh, you know, I've actually picked a bad example here. I picked a bad example here. Not good at all. I must find another one. Because I can't. It was better.
Okay, I see that. Settler, set greeter, get. Okay, understand.
Right. That was obviously, you see, this is the thing with IO servers. You customize the IO server to provide the services for that file. Now, obviously, a logical file has read only. You can't provide insert, update, or deletes, or can you? You know, you customize each file for the purposes for which it's intended, the IO server. So there's the delete, there's the set lower limits. Now we're getting it, right? And set greater than, get. This one is also, I put this in, it's to save the current position. I save the key, save the record.
Mhm.
And then, of course, the PR is to reset to last saved position. This is sometimes necessary if you want to save a position and go back to it. It's in here, it's in the template as well. But obviously, if you don't want it, you can take it out. The reason for this, if A1 is a C or an X, because I started this whole thing using X for close. So some of my IO servers use X, some use C. So I set up a template that looks for both and then does a close. Very seldom use it, but it's there. And here you have your error not supported operation. So there are your actions, available actions. In the get procedure, which is the actual read, you get the second thing. You get read with a blank in action 2, which says read using full keys. In fact, that's just a flat chain using the whole key. N, read the next record. P, read the previous record. Those are used only after you set lower limits or set greater than. Okay? Read forward 1 record, read backward 1 record. So all of these, here is your get next procedure. And of course, something that I have been irritated with for years is this percentage KDS structure. Actually, I haven't lately had a look at it to see whether they've actually changed this, but the second parameter has never been a variable. As a result, you have to do, if you've got 3 keys, it's got to be done 3 times, which has always been a bit of a nuisance. I wonder whether they've actually changed it. Come on. When my computer's dying. Got so many windows open, it doesn't know where it's going. Okay, anyway, not serious. This number, I always hoped it would be a numeric, because then I would know how many keys there were and I could do 1, 2, 3. But this had, if there are 3 keys, you have to do it 3 times. Number of keys is 1, number of keys is 2, number of keys is 3. And this just is a partial read based on the number of keys. Let's get next. Get previous is exactly the same, only backwards. It's a read previous equal. And set lower limits. Once again, different with different key levels. And so on. This is all custom built. And this is a style of IO server that has served me very well for years. Now, I know I'm scrolling through this and I've read this code. I know this code backwards, but you are looking there and probably with a bit of a shocked expression, not quite knowing where to go. You are going to be able to build your own IO server and you're going to take it apart on the 2 programs that you have. And this is basically where I'm heading to have a look at how you are going to generate your own IO servers for these 2 files that you've got in your program, in your library that we've both got. Because I'm going to generate and you're going to generate. And then we're going to look and see whether we've got the same code. How's that sound? Bit of a game. Right, so.
Call me Diane.
Oh, Diane, yes, sorry.
Yeah. in your example, you have you have variable A1, variable A2, and variable no key, something like that. I would just want to where they are defined.
Okay.
And they come from where?
A is a parameter. It's the first parameter on the call. Okay. It's a 5-character. It was originally designed to allow for up to 5 characters. I've never used more than 3. What I do is I take A here, A, and I move it into action there, which breaks it up into A1, A2, and A3. So this is the action indicator that is coming in from the client program, telling me what to do with this IO server. So if A1 was an I, I'm doing an insert. Okay, so A1 is IUDSGR. The whole action can be PS, PR, or A1 can be C, or A1 can be X. So those are the values, the actions that the IO server is required to perform, which can be, as I say, I've used 1 all the time, 2 occasionally, and 3 rarely. One of the things I like about what the IO server can do for me is, have you often tried to update a record that isn't there? Have you ever had that situation? Because it's one of those features that I built in and find it very useful. The first thing I do on update is I take the key and I chain to the record and put the record into a saved data structure. Okay. Then, if I found it, I do the update. But if I didn't find it, and A2 is I will go and insert it. So if my action call to the IO server is UI, it says, please update the record if it's there, but if it's not, insert it. And I found that a very useful opcode that you don't get without an IO server. All right. Answer the question, Diane?
Yeah.
You're happy with that? Okay. Super. You must remember these are IO servers that have evolved over the years. I'm so used to them, I sometimes do forget that this is new and is sometimes utterly confusing to people, and I apologize for that. Please take the time to look at the code. I'm sure you can all read RPG. Is there anybody there that can't read RPG? Because if there is, you shouldn't be here.
Tommy, I have a question.
Yeah.
Well, I know that your IO servers are doing commitment control.
Yes.
But very often we have several files to update. So commitment control must be controlled at the application level and not at the database level. So how do you do that?
Well,
is that a good question?
Yeah, it's a brilliant question. It's actually one I've been waiting for. Well, yeah, it is. I specify that file is committable. Okay. i.e., the file is under commitment control. But if you look here at the put statement, you will see there's the write.
But no commit.
Don't worry about that one. Yeah, and then immediately a return. There is no commit stroke rollback statement in an IO server anywhere.
Okay.
The responsibility for commits or rollbacks is entirely in your application code. That means you
Okay.
can call a dozen IO servers, and then you do a commit. And all those changes will be committed at once.
Okay.
Or, of course, if you exit the activation group, the commit will happen automatically without you having to do anything about it. But it is, you were quite right, absolutely 100% correct. It is the responsibility of the client, not yours, not the IO server.
Yeah.
Okay.
But I have another question following the burner question then. In the way that we are doing an update of a record by the IO server, commitment is not done yet, but at the same time, another program using the IO server to read the data. Does the data will come back with the new information or the old information because the commit is not yet done?
The way, oh boy, that was a nasty one. Is that you, Francis?
Yeah.
Yeah.
Good question, Francis. Good question.
Absolutely.
I like that.
That was a nasty one. The rules are the same, whether you're using IO servers or whether you're using FSpecs. Sometimes you will get the new data back, and sometimes you won't. I have never really been able to work out what it is, but most of the time, the way the commitment control works on the IBM I is very different from most systems. On most systems, when you do an update, the update is held back, right? And is buffered, but the file remains in its original state. And only when you commit do all the updates get applied to the record. That is typical of most systems that I know. The IBM I does it backwards, because the IBM I designers and architects felt that the rollback function was only in cases of error, which hopefully don't ever occur, or very, very low percentage. So what they do is they do the update to the record. Immediately your IO server or your program does the update, the record gets updated. Okay. It is locked so that you can't read it for update again. That's the point. You must understand. If another program tries to read for update, it's going to get locked out. But if it's reading for input only, it's likely to get the new record. But again, it's a timing issue. Remember, this machine works like lightning fast. But if one application updates a record at the same instant as another application is trying to read that record, your guess is as good as mine. I don't know which comes first, and this is a case of the chicken or the egg. I'm not sure.
Okay.
So most of the time, it will be. It'll be fine. I use that philosophy when I'm, when you have a file that's got a sequence number on it and that you may want to insert a record with the next sequence number. I always go to the end of the record, pick up the last record, add one to the sequence number, and come back again and add it to the file. Now, that potentially can give you duplicate numbers, but I've never had one ever. I do it that way rather than storing next number in a data structure or a data area, because next number in a data area actually can cause more conflict, because the data area is updated differently to a physical file. So I have never had problems. I would say probably that most of the time you will read, as long as you read for input, not for update, you will get the new record off the file, pretty much.
Yeah.
Okay. All right. Let's see. I've got okay. next story is is the fun part. I like this part. But I'm going to now, obviously, you could generate IO servers simply by taking a sample of mine, copying the source code, and modifying it to suit yourself. However, I realized very quickly that most of these IO servers are almost exactly the same. So one afternoon when I had nothing else to do, I created a program generator for AO. That was a lie, but you understand what I mean. And it's called generator templates, maintenance. And now these are templates. I don't know whether you've looked at the templates that you have, Bernard, on your system at the moment.
No, first time I see that.
First time you see them. All right, this is in my development environment, I have to be honest. And these are all different templates. Right. Let's look at this one here, which is the template for standard IO. That's just the normal type of IO with nothing fancy. Notice the one above is read only, which I use generally for logical files that you can't update, like joins or views. And this one here is used, the third one down there is used for when you want the IO server to talk to the trigger program. We will discuss that maybe a long time in the future. But the one that's most commonly used is this conventional standard update. And I've got a generator that creates these templates. And I'll show you this one. This view is a view. It's nothing more than a view. You can't edit it. It just is a template. And the template is designed in such a way that the bar, and this, you mentioned this earlier, Bernard, we might have a problem with your CCSID 500 where this bar doesn't quite work for you guys. We're going to have to find that one out. And if it doesn't, I'm going to have to make a change or two, but that's not too difficult a problem. Okay. But the bar says start substitution. Then there's a keyword following the bar, which says what I'm substituting, and the full stop ends the substitution. Now that is substituting the file name from AO. Okay. Here's a substitution of the key string. There are various substitutions. You'll notice it's put in the includes for the error handlers. Now you would have to change these templates to ERR if you want to use your error handlers. You follow me?
Francis, did we just keep the name, or we did change for ERR?
I gave you ERR.
Oh, you gave us ERR. All right.
I gave you ERR because I went. That's why I said to Neil the last time. I said rather
yes,
don't.
We've got ERR.
Oh, okay. So wherever these templates are ERH, you're going to have to change them to unless I do them for you, which I can probably do when I give you these templates because you don't have them yet. I will give them to you for tomorrow. Okay. This template will be there in your drivers for tomorrow. But you can see there's the name of the program. There's a file key, file name K. This is why my naming conventions are so rigid. File. All of this substitution, all the heavy donkey work code has been done. And all you need to do is you need to substitute. File R is file record name. So on and so forth. These should be fairly easy, but there is a a link in the help text. Not in this help text, obviously in the other help text. We have a website, a wiki page that actually has the instructions on how this template is put together. But let me say the template is there. I will give you the template and I will show you how you deal with it. Okay, here is the template. Here is an import and an export function. You can export it to a schema, a source, and a member name.
Mm-hmm.
Choose any one you like. You can then edit it using RDI, and then you can import it from wherever you had it. So this import export is simply export it to a source member, modify it with RDI, and then import it back into the generator. I wasn't going to build an entire editor just for this. So you got import export. All right. Now, how do we use these templates? Well, they're actually rather easy. And how to build an IO server? I will build you an IO server right now, very quickly. I go to AO Program Generator. I double click on the template name and I choose the template. I then pick up the system name, which you should also have registered there. I'm going to put it into there, and I'm going to pick up the one that we just found there. It fills in everything else using the naming defaults that I have. So that is the parameters for generating an IO server from a template. I can click F3 to generate, and it says to you, this program already exists, and therefore I can't generate it again, because this is a template generator. If you go and change the code after you've generated it, you're going to lose those changes if you regenerate it. Okay. I haven't created something of immense sophistication. That's why if the program already exists, I won't generate it. You have to then deal with it yourself. However, if I change this name just for and show you just how fast this is, that's 110 $. I just put an X on the end. Now I can generate it. And that's the speed. I'm going to bring this back here. And I'm going to refresh this. There it is. It's been generated. And there is the code that was generated just now from that template generator. You will see it's got the file name, it's got the IO server name, which is the modified name that I put in, and it is a completely standard IO server. It's a module. Okay. Any question about that?
But what's about the system name? In our case, is it AB Canada or?
It will be whatever you've configured into AO. I'm not sure what that is.
It's AB Canada.
AB Canada. So it will be the AB Canada you select. Then it will list the files that are schemas that are there. You choose the schema and you can put it in. So it should not be any more difficult than that. As you can see, there are a number of them. I will pass this one, the read-only one, and that standard one. I will send through to you probably later on this afternoon or tomorrow. Okay. I will probably make the changes as well, and I will actually stick them into your, where should I stick them? Because it's easier for me to log on to your machine and actually just move them through RDI onto your machine. So I'll do that. I'll sort it out, and I will then send you an email, Bernard, to let you know where I put them.
Yep.
It'll probably be in one of the AO Canada libraries or whatever. Okay. That is it for the day. It's pretty much on time tonight.
Yeah.
Not that pretty
Surprisingly.
Surprisingly, yeah. I thought I was going to overrun. I know I've run through this, and I know it's still very fast. I'm trying to slow it down, but it's still fast. Are there any questions?
Question is, IO servers, I know that you put them all over the place, but to start with, well, what kind of table would you start with?
If you were, obviously we're going to do the exercise on the two tables we've got, but where I would start would be actually, it's a matter of pick a file, any file, to be honest with you. Possibly one of the files, one of your master files, for example, maybe a client file, a customer file, something that's doesn't have millions of transactions running through it on a daily basis, because you want to experiment first, Bernard, with this thing. You want to write a program. These two files, these test files that we're dealing with, I presume that one of them is a header, an order header, is it? And one's an order detail?
Yeah.
And there must be a program that actually updates the header and the detail. Is that your order entry system?
That's the production order.
Okay. And is it one program?
Yes.
Yes. Well, there you are. That's where you start.
Tommy, we've got a lot of a table with, a table data. It means that that's not a transaction file. This is a table with different value for example, a reference, yes. And in this case, we've got only one program doing an update, and all the other program is using to read the database. Then it could be a good beginning to use this kind of file.
You could use that. Use that file, create an IO server for that file, put it into the maintenance program, and make sure that it's maintaining the file correctly. Then start maybe inserting the IO server in one or two of the programs that read that file.
Mm-hmm.
I presume you have a test environment for testing changes to programs.
Yeah.
You don't just make modifications in production, do you?
No, we don't. And what about whenever, let's say we change a file structure, okay, we add up a field or anything. So the other day you were mentioning anything that you add to a file should be added to the end of the file. That's good. But let's say we add that field, then of course we're going to recompile the IO server and probably all of the triggers accordingly. But what about the programs that is using this procedure?
The IO server.
Yeah.
They need to be changed as well. Remember, in the program that uses the IO server is the record buffer. Okay. And that record buffer, if you add a field to the bottom of the file, that record buffer changes. So you need to actually make that change in the program
Okay.
Now, if you use externally described data structures, which I strongly recommend you do, then you'd have to do no more than just recompile that program, unless you are intending to use the extra field. But then if you're going to use the extra field, you're going to have to compile it anyway. So yeah, it's the same old story. People seem to think there is a magic wand that allows you to change physical files and not to recompile anything. And there is a magic wand. If you want to go out and buy it, it's available in the shops. It simply means that you have to then change all your I/O, every bit of it, to SQL. And not just select star from. You have to name every single field you're reading and writing.
Yeah.
That's a very big, very heavy, and very expensive magic wand. So that's the only, nobody has ever come to me with any other way of being able to change a file without changing the programs that deal with that file. It's just never seen it. And the only thing you can do is to make it as simple as possible. Now, you've got ArcCAD, you should be able to scan and find all the programs that are using a particular file or a particular I/O server.
Yeah.
And if you can, those you recompile. I mean, it's the way you've been doing it. How many years now? 35, 40?
50.
50. Enough. So one that I hope that I could invent that magic one, because it would make me very wealthy, but haven't come across it yet. Yeah. Okay. All right. You have to create. There's one thing I forgot, which I need to actually show you. Here in my let me just what I do is because each I/O server is a module, all right? So what I've done is I have created here I/O servers. This is my naming convention for service programs containing I/O servers. In my case, it's AOF iOS1. That means it's an I/O server for all files in AO beginning with 1. It's the 100 through to the 199. And I create the binder source, which I've got here. And I create the compiler program, which I've got there. Right. Remember what I said about the binder source? That you need your binder source for every single service program you create. You will notice the signature on this one is already V2R4. It means it's gone through actually a number of complete regenerations. And if you look at the number of I/O servers there are in the service program, there are a few. These are all I/O servers. This one here is for a physical file. This one here is for a logical file, because it's got a letter after the F. Makes it a logical file. It's probably a read-only I/O server. This is my convention for file naming. Fs and then just another one, a letter. And the dollar at the end indicates that this is an I/O server module. And you will notice that export symbol, and you'll notice out of sequence stuff at the bottom here, because those were added. And what did I say? One of my rules was always add to the bottom of the export symbol table. Never change the sequence and never remove anything. So that's the binder source for my I/O server AOF iOS 1 at that. Here is the compile program. And this is a list of each module.
Okay.
It matches the binder source on the other side. Only this one can be in alphanumeric order. That one can't. The binder can't, but this can. So at least I got my OCD half satisfied. These are a list of the modules. There's the source file. There's the binder source name. These are the other service programs that are used by this one. Notice the error handler is one of them. You will have the same in yours when you do it now, ERR, SRV at. And of course, user profile, and there is user star owner, i.e. adopt owner authority when you are using this service program. So that those are obviously, in the case of your homework for next week, you'll only have 2 entries in the binder source, and you'll only have 2 entries in this modules list. And you can compare and see how you did the error handler, because in fact, you're generating another service program. You put it into the same binding directory as your error handlers, so it's accessible by any client that wants to bind to it. Okay.
But the homework, Tommy, is it to create that service program, this IO server against the test, the development or the test library, or against a production file?
Well, this one is I think this one's in the this one's in the production library, but you notice what I've done here. I've put current library in that program, and I've got current library there as well. So what I normally do when I run this thing and I want to compile an IO server, if I want to compile it in my development environment, I just switch my current library to the development environment and run this program. And then it will compile it and create it in the current library, which is the development library. And then I just remove the current library off the library list anyway. And it will search for all these things in the library list. So I put the current one at the top, and that's where it finds most of the stuff. Anything, in fact, if I take that module, for example, and I pull it down into the development library to change it, and I don't change any of the others, I always have my development at the top and my production libraries at the bottom. It will compile, it will find this one in the development environment, and it'll find all the others in the production environment, and it'll still compile a development service program.
Okay.
With me. You're going to have to play with it and experiment to see how it goes. But if you made the error handlers work, this should be not a problem. And you've got to do it for 2 files. So what I'll do is I will be sending you the templates for the IO server generator. Oh, yeah. And the copybook, of course. You've got to use the copybook. I thought I was finished, but no. Up here, I will send you these two, this one as well. That is the copybook.
Okay.
Okay. Which you can also generate and include in the programs. All right. I'll send you both of those. This one is easy to generate. It's just exactly the same technique. You just go into the generator and you just select it and generate it. And of course, it doesn't compile. It only gives you the source code. That's all you need, the copybook.
The copybook for the IO server is 2 is to the code that we need for the program calling the IO server.
Yes, yes, it is.
I'm right? Okay.
Yes.
Just want to be sure. Okay.
Because
this is the code that we need to. Okay.
What you need to do is you need to take this line out of the copybook, put it into your program, and take away the comment line, so that it's the one slash. So it's a slash include statement, and that includes this whole thing.
Okay.
That whole, in fact, it includes this whole thing here. It includes this in your source program.
Yeah.
Which of course you don't see, but it's all very consistent. So you don't really need to know because it's always the same. Okay. I hope you do have fun this week.
I did.
You did. Okay, guys, I think I'm done. Please, I'm here this week. So if you have any questions, go to Neil.
Okay.
If Neil says, nah, talk to Tommy, then talk to me.
All right.
Okay.
Thank you very much.
It's a pleasure very much. You go well, guys. Have fun. And I mean it.
Okay. All right.
Ciao then.
Bye now.
Enjoy.
Bye.
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 Bye-bye.
Bye.